Hi, I am Prathami and I welcome you all to this new video on the 24th universe. Today, we are diving into the world of software development lifecycle, in short, SDLC. In this video, firstly, I'll take you through the structured process that developers follow to create and deliver software using modern tools and practices. We'll explore each phase from planning to maintenance and look at the tools and trends shaping modern software development. Next, we'll explore popular SDLC models like Waterfall, Agile, Scrum, V model, Iterative, Spiral, DevOps, and Lean software development. And to make it real, lastly, we'll walk through an example of developing an e-commerce website. Here, what is done in each stage and what tools are used will be explained but not code. Code will be explained maybe in the future videos. So, stay tuned. In simple terms, software development lifecycle is a process to create software products. It is a framework that outlines the steps involved in creating software. It aims at two things. First, to provide high quality software solutions that meet all customer requirements. And second is the software should be created on time and within budget. SDLC also means System Development Life Cycle, which is a broader term. But here in this video, we are going to see software development life cycle in detail. It consists of different phases like planning, analysis, design, development, testing, deployment, and maintenance. Let's explore each phase in detail. Software development lifecycle is the process of developing software products. It focuses specifically on software products like desktop applications, websites, and mobile apps. System development lifecycle refers to a broader process of developing entire system including both software and hardware. It considers the whole system architecture, which includes computers, servers, networks, databases, and sometimes human processors along with the software. The stages of software development lifecycle are planning, analysis, design, development, testing, deployment, maintenance. System development lifecycle are planning, system analysis, system design, system implementation, system integration and testing, and system maintenance. Software development lifecycle examples are mobile apps such as Instagram, WhatsApp, web apps such as Amazon, Facebook, and desktop apps such as Microsoft Word, Adobe Photoshop, healthcare management software, etc. System development lifecycle examples are hospital management system, air traffic control system, banking system, telecommunication systems, etc. From this, it is accurate to say that the software development lifecycle can be considered a sub-process of the system development lifecycle. For example, hospital management system consists of the following sub-process: hardware, where servers, workstations, medical devices, network setup, etc. Software, which consists of electronic health record software for managing patient data. Database, a centralized storage for medical records, and networking, configuring the network to connect the hospital's various systems. In this case, the software development would be used to develop the EHR system, that is the electronic health record software, to manage the patient data. Now, I hope the distinction is clear between the software development lifecycle and the system development lifecycle. You might wonder why database is a separate sub-process and why not it is the part of the software. While the database itself is a software, it requires physical storage and processing power to function. This is where hardware comes in. Database servers are the machines that store and manage data physically. It includes deciding where the database will be hosted, on premises server or the cloud, how much storage capacity, RAM, and processing power are required for optimal performance, etc. Now let us resume our topic. We are now seeing the different stages of software development life cycle in detail. The first phase is planning. Here, we define the scope, estimate cost, resources, and timelines. This is where you identify stakeholders, gather requirements, and plan how to proceed. The key activities carried out in this phase are feasibility study, assess the financial, technical, and operational feasibility of the system. In short, to know the project is practically possible or not. Risk analysis, identify potential project risk and define mitigation strategies. Requirements gathering, discuss and document the client needs. Tools used here are Jira or Trello for task management, Microsoft Project or Asana for project planning, Lucidchart for creating project workflows and visual planning. The next phase is gathering and analyzing requirements. We meet with stakeholders to understand both functional and non-functional requirements here. This is documented and used as a blueprint that serves as a reference for the development team. The key activities involved in this phase are requirement documentation, create a detailed documents outlining system functionality, functional specification, define how the system will behave in various scenarios, non-functional specification, define performance, security, and usability criteria. The tools used here in this phase are Confluence or Google Docs for documenting requirements, UML diagram using draw.io or Lucidchart to visually map systems behavior, business process modeling tools like Visagi or Camunda to model workflows. In the design phase, the requirements are converted into detailed system architecture and design. We start with the high-level design, breaking the system into components followed by detailed low-level design. The key activities in this system design phase are high-level design, that is HLD. Here, we define the overall system architecture, including modules, components, and their interactions. Low-level design, that is LLD, it focuses on specific components and algorithms, including database schema. API designs and user interface layouts are mapped out. The tools used here in this system design phase are Figma or Adobe XD for user interface design, ER diagrams using MySQL Workbench for database schema design, UML and architectural diagrams using Lucidchart or Visio. Development is where the actual coding happens based on the design documents. This phase involves both front-end and back-end development and follows the coding guidelines established earlier. The key activities involved here are coding, that is writing the source code using programming languages, frameworks, and libraries. Code reviews, reviewing the written code to ensure quality and adherence to standards. Unit testing, testing small chunks of code or functions to ensure they work correctly. The different tools used in this development phase are GitHub or GitLab for version control, PyCharm or Visual Studio Code or WebStorm as integrated development environment, Docker for containerizing the development environment, CI/CD tools like Jenkins for continuous integration. The objective of testing phase is to ensure that the software meets the specified requirements and identify defects. Testing can include different levels such as unit testing, integrations testing, system testing, and user acceptance testing, that is UAT. The key activities involved here are test case creation, that is, writing test cases to cover various functional and non-functional scenarios, bug reporting and fixing, identifying bugs, logging them, and assigning them to the development team for resolution, performance and security testing, ensuring that the application can handle load and meet security standards. The different tools used here in this testing phase are Selenium or Cypress for automated user interface testing, that is UI testing, JUnit or PyTest for unit testing, Postman for application programming interface testing or API testing, JMeter or Gatling for performance and load testing. Deployment involves realizing the application to a live environment where end users can access it. Deployment includes configuring servers, setting up databases, and ensuring the software runs smoothly in its final environment. The key activities involved here are deployment, uploading the code to the production environment, continuous delivery, automating the deployment process through CI/CD pipelines, environment configuration, setting up production environments, including scaling for cloud deployments. The different tools used here are Docker and Kubernetes for containerization and orchestration, AWS Elastic Beanstalk or Heroku for automated deployment, Terraform for infrastructure as code, Circle CI or Jenkins for CI/CD automation. Even after deployment, software requires ongoing maintenance. This includes fixing bugs, implementing updates, performance improvements, and handling customer support. The key activities in this phase are bug fixes, fixing issues reported by users or identified through monitoring, updates, adding new features or improving the software based on user feedback, monitoring, using tools to track the performance, availability, and security of the system. The different tools used here are New Relic or Datadog for performance monitoring, Sentry or LogRocket for error tracking, AWS CloudWatch for monitoring and cloud-based deployments. What are SDLC models? Software development lifecycle models are structured processes used to guide the development of software applications from initial planning to deployment and maintenance. They define the steps and stages that a software project goes through and provide frameworks for managing the complexities involved in building software systems. Look, different SDLC models exist because every software project has unique needs. Some projects require rigid linear process while others need flexibility and rapid delivery. Some projects involve high risk, so depending on the project needs, we can choose from the various SDLC models. There are several SDLC models such as Waterfall, Agile, Scrum, V-Model, Iterative, Spiral, DevOps, Lean Software Development, and so on. Let us know them in brief one by one. Waterfall model is a linear sequential approach where each phase, like planning, design, development, testing, deployment, must be completed before the next phase begins. Waterfall model is used in projects with well-defined requirements that are unlikely to change. The characteristics of waterfall model are it is rigid and less flexible for accommodating changes mid-process. The example companies that use waterfall model are NASA, large government projects. Agile model. Agile model is an iterative and flexible approach where work is done in small increments called sprints. allowing for continuous feedback and adaptation to changes. Agile model is ideal for projects where requirements may evolve and constant interaction with stakeholders is needed. The characteristics of agile model are: it is highly flexible, focuses on customer feedback and incremental improvements. The example companies that use agile model are Amazon, Microsoft, Spotify. Scrum model, a subset of agile. A Scrum is an agile framework that organizes work into time-boxed iterations called sprints, typically lasting 2 to 4 weeks. Scrum model is used when teams need to quickly adapt to changing requirements. The characteristics of Scrum model focus on teamwork, iterative progress, and product backlogs. Example companies that use Scrum model are Google, IBM, Salesforce. V model, that is validation and verification, is an extension of the waterfall model where each development phase has a corresponding testing phase, ensuring validation at every stage. V model is used in safety critical applications where testing and validations are crucial. The characteristics of V model emphasizes rigorous testing, making it suitable for high-stakes projects. Example companies that use V model are Bosch, Siemens, often used in automotive and medical device software. Iterative model involves building an initial version of the software, testing it and improving it through multiple iterations until the final version is ready. Iterative model can be used in projects where requirements are unclear and evolve over time. The characteristics of iterative model are: it allows for ongoing adjustments and improvements. Example companies that use iterative model are IBM and Motorola. A spiral model is a risk-driven model that combines elements of iterative and waterfall models, emphasizing risk analysis at every iteration or spiral. Spiral model is used in the projects with the high risk, such as financial or large-scale enterprise softwares. Characteristics of spiral model are: focuses on risk management and iterative progress. The example companies that include spiral model are AT&T, Fujitsu. Next is DevOps. While not a traditional SDLC model, DevOps is an integration of software development dev and IT operations op to improve collaboration, speed, and continuous delivery. We can say that the development and operations are the two sides of the coin. How DevOps came into being and why is it so popular? Well, long story short, around 2007 and 2008, when the development and operations were a kind of enemies to each other, constantly crossed swords. Development would throw the code over the wall to operations, and operations had no choice but to deal with the mess. Operations would not proceed further, assuming that the code had issues, and the development would not bat an eye, assuming that it is the responsibility of the operations team to deal with it and correct the issue. This would result in delay in delivering the software product. But then, some great souls called software engineers decided to break the wall and created DevOps. Development and operations realized that they were the two sides of the same coin, working towards the common goal of delivering the quality software on time. What exactly happens in DevOps is the development team and the operations team is made to work together, and almost every task is automated. This results into faster and reliable delivery of the software product. There is an evolution of the DevOps methodology already, known as DevSecOps, that integrates security practices directly into the DevOps process, emphasizing the need for security to be a shared responsibility throughout the development lifecycle rather than being an isolated or a final step. DevOps is ideal for companies looking to achieve faster release with high reliability. The characteristics of DevOps is automation, automating repetitive tasks like testing, building, and deployment, continuous integration, that is CI. Developers frequently integrate code into a shared repository where automated tests are run. Continuous delivery, CD, automating the release process to deliver updates to production faster. Monitoring and feedback, tools that help monitor the health of an application and provide feedback on performance. The example companies that use DevOps model are Netflix, Facebook, etc. Next is lean software development. Based on lean manufacturing principles, it aims to deliver software faster by reducing waste and maximizing customer value. Lean software development is suitable for projects where efficiency and eliminating non-value adding processes are crucial. The characteristics of lean software development include it emphasizes efficiency and eliminating waste in the development process. The example companies that use lean software development are Toyota, Ericsson. The last one we are going to discuss here is a prototype model. In prototype model, a simplified version of the software called a prototype is developed to help understand and refine user requirements. Once the requirements are clear, the prototype is discarded and the actual system is built from scratch. Prototype model is suitable for projects which involves UI UX design, app development, and early stage startups. The characteristics of prototype model are quick initial development, iterative refinement, prototype is disposable, reduce misunderstandings since there is high level of user involvement. And the example companies that use prototype model are Adobe, Microsoft, startup companies. Let us consider an example. Assume that we are creating an e-commerce website. So for an e-commerce website, you might define the scope as building an online platform with features like product browsing, a shopping cart, and the payment gateway. The requirements might include functional. User should be able to browse products, add them to a cart, and check out securely. Non-functional. The website should load within 3 seconds, be accessible from mobile devices, and handle up to 1000 concurrent users. Design might include database design for storing products, orders, and user data, architectural components like microservices for order management, product catalog, and payment integration. Developers would build front end using the React.js or Angular, set up the backend API using Node.js, Python, Django, or Ruby on Rails, develop the database using the Postgres or MongoDB. Testing could include unit tests for each individual feature such as adding items to a cart, integration tests to ensure the cart, payment system, and user account systems work together, load tests to verify if the website can handle 1000 concurrent users or not. Deployment could involve deploying the application to a cloud platform, say for example AWS or Google Cloud or Microsoft Azure, setting up Docker containers for microservices, and using Kubernetes to manage scaling and high availability of the website. Maintenance could include regular updates to improve security, such as patching vulnerabilities, adding new features like discounts or a recommendation engine. monitoring site performance to ensure it stays fast and responsive. In this dynamic world today, Agile, Scrum, and DevOps are the most popular SDLC models. These models are chosen for their flexibility, adaptability, and ability to deliver software quickly and reliably. Some of the well-known companies like Amazon uses Agile and DevOps for continuous feature updates and quick deployments. Netflix relies on DevOps for automation, continuous deployment, and fast release cycles. Microsoft adopts agile methods for building its cloud and software products with regular updates. Google uses combination of Scrum and DevOps to manage large-scale projects and ensure rapid development. Spotify heavily invests in agile frameworks like Scrum for team collaboration and rapid product improvements. IBM uses iterative and Scrum models to handle long-term evolving projects. Why SDLC matters is that the SDLC ensures that software is built in a structured and systematic way, reducing errors and ensuring high-quality outcomes. By following SDLC, teams can deliver software that meets users' needs efficiently and maintain it over time. Thank you for watching this video. I hope you found it helpful. If you would like to get the notes for this tutorial, just drop a comment below with the word SDLC notes followed by your email address and I'll send them right over. If you have any questions or doubts, feel free to ask in the comment section below. I'll be happy to help. Don't forget to share this video with your friends, students, or anyone who might find it useful. And of course, if you enjoyed the video or learned something new, please give it a thumbs up and hit the subscribe button for more tutorials like this. Thanks again for watching and I'll see you in the next video.